Okay, year 11, mathematical method, video 20, this should be 28. And we're going to do addition rule of probability in this video. Okay, so let's see what do you mean by addition rule. Addition rule means if there are two events, okay, so the union of two events. Okay, so this is what we call union. Still remember union? The union of two events, the probability of that union of two events equals to their respective probability, and then you take away the probability of their intersection. Okay, so basically the probability of union of two events equals to the sum of their probability take away the probability of their intersection. Okay, and why it is so, let me just give you one very simple explanation. Right, so let's consider if we have Venn's diagram. Okay, so for this Venn diagram, let's indicate that's the number of elements. Let's say here's got 6, here got 3, and here I got 5, right? Okay, so that's what we call A, that's what we call B. Okay, so let's just see the number of elements in A. In A, the circle, there are 9 of it. In B, there are 8 of it. And the union of it, that means you need to add all the elements together. So that should be 14, right? And you got intersection, which is 3. Okay, so you see what happens if we add that's A and B together, then you got 17. Okay, so 9 plus 8 is 17. So 17 is more than union. Union is only 14. Why? So 17 and 14, when you compare, is 3 more than what we need in union. The reason is if you add, okay, let's highlight. If you add A, that means you add the whole orange circle, right? But when you add B, that means you add the whole purple circle. You see the intersection part, that's the 3, that's region we add twice. The first time is belongs to A, second time belongs to B. So when you just add the number of elements in A and number of elements in B, that's the middle, the overlapping region, you add them twice. You add it twice. So that's why it's more than just the total number in 2 circles. Alright? So that's why you need to NA plus NB take away N intersection B equals the union. Okay, so that's for number of elements, but we understand that probability just about the number of element in the subset, which is what we call events, divided by number of total element in the universal set. All right, so that's why for probability it will happen in a very similar fraction. Okay, so the rule actually is for any events. So all events you can apply this addition rule. So you just apply it, that will be fine. But there's some event we call mutually exclusive. Mutually exclusive means A and B cannot happen together. In terms of probability, that means the intersection of A and B got probability 0 because they can't happen together. So that means when you ask A intersection B, there's no intersection actually. So the probability of that is 0. Okay, so when you think about this, all right, so probability A intersection B is 0. So that means when you change that formula a little bit, so that formula becomes the union A and B, the probability equals probability A plus probability B minus 0. Okay, since that's minus 0, don't need to write it. So that's why when only when it is mutually exclusive, then the probability of the union of two events, okay, you can write as the sum of the two probabilities. All right. Otherwise, you have to take away that's the intersection of two. The probability of the intersection. Okay, let me give you some example of mutually exclusive events. For example, getting a 6 by tossing a die, and B getting a 3 by tossing a die. When you get 6, that means you can't get 3. You can't get it at the both at the same time for one toss, right? Getting a spade, getting a heart. Okay, and because spade and heart belongs to different different suits of the playing cards. So when you just draw one card, you can't get the get different suits by just drawing one card. All right. A taking a flight from Mackay to Brisbane, driving from Mackay to Brisbane. Okay, of course they can't happen at the same time. Okay, unless you go from Mackay to Brisbane twice, but if you only do it once, you have to decide which mode of transportation you need to take. All right, and for examples, so not mutually exclusive event, getting a 6 by tossing a die, getting a number greater than 3. Of course, you see that's getting a number greater than 3, including 6. So A and B, they are not mutually exclusive. Okay, getting a spade by drawing a playing card. Okay, getting an ace, because that's one card we call spade ace, right? So where's the spade ace? Means this one. Okay. So that's a spade and also an ace. All right. Okay, so it's not mutually exclusive. You can have them both have that. You can have them at the same time. Okay, and taking a flight from Mackay to Brisbane. Okay, driving back to Mackay from Brisbane. Okay, so these two events are not mutually exclusive. You can take a flight from Mackay to Brisbane, and then you buy a car in Brisbane. That's what I did last year. Okay, then you drive from Mackay to Brisbane. Okay, so they are not mutually exclusive. All right. Okay, so remember for the first three, for this what we call mutually exclusive event, you will say the probability union of A and B equals probability of A plus probability of B. Okay. For not mutually exclusive events, then it's probability A plus probability B minus probability A intersect B. Alright. Okay, so let's give you some example. Okay, if one card is chosen at random for playing getting a spade or a heart. Okay, getting a spade. Okay, so spade means the last row, the suit of last row. Heart means the first row. Okay, so heart and spade, they can't happen together, right? They can't happen at the same time. So let's say this is what we call event A, this is what we call event B. So for these two events, they are mutually exclusive, alright? So what you need to write is possibly just A or B, and since they are mutually exclusive, you just add them, okay? And spade, you got 13 of it, and heart, you got 13 of it. So that's 26 out of 52. That's 1/2. Okay, and then the next one, if you got spade or a king. Okay, so this time they are not mutually exclusive. Why? Okay, when you see this, we could actually find a spade and a king. Okay, so yeah, here it is. Okay, so this one is a spade and a king. Alright, okay, so that means this is not a mutually exclusive event because you can both be a spade and a king. Alright, so for this one, if I set this as event A, this as event B, then I'm going to find the union because they ask getting a spade or a king. So when you see the word like or, it means union. Alright, okay, so PA plus PB, but this time you have to take away PA and B. Alright, PA is a spade. Spade, you got 13 of it. Kings, you got how many kings? Let's track how many kings. Okay, 4 of them, right? So you got 4 of them, and you need to take away when it happens at the same time a spade king. If that's a spade king, so that's only one of them, so take away. Alright, so that's 17 minus 7, 16 divided by 52, and 16 divided by 52 is 4 over 15. Alright, so you see the difference between mutually exclusive event and non-mutually exclusive events. So how could we deal with them? Right? Okay. Right. So move to next one. If one common die is tossed and the number facing up is taken, calculate the probability of either getting a 6 or, so you see, or a number less than 3. So against union. Okay. Getting a 6, so let's say getting a 6 is A, less than 3 is B. Okay, so getting a 6 means 6, right? Less than 3 means what? Means you could have 1 or 2. Okay, so 1 or 2, when you compare with 6, they are mutually exclusive. You could get 6 or you could get 1 or 2, but you can't have the both, right? So for A is mutually exclusive, so we will have A or B equals PA plus PB. Okay, let's think. How about PA getting a 6? Just 1 out of 6, where that 6 faces. Number less than 3, you got 2 out of 6, so that's 1/2, isn't it? Alright, okay, so for B, to for that. Oh, ugly. Okay, so for next one, getting an even number. Okay, even number, which is A, or okay, that means union. Multiple of 3, that's B. Okay, even number means 2, 4, 6. Multiple of 3, you got 3 and 6. Okay, so when you compare two sets, are they mutually exclusive? No. You might get 6, then you satisfy both an even number and a multiple of 3. Okay, so for this one, they are not mutually exclusive anymore, so you need to do this. Okay, probability of A, that 3 of them, 3 over 6. Probability of B, that 2 of them, 2 of 6. Take away the intersection, which is 1 of 6. Okay, so that 4 of 6, 2 over 3. Okay, that's it. Okay, And sometimes it would be easier to draw a Venn diagram to include the two events under consideration. There are two types of Venn diagram. One indicates number of outcomes, the other indicates the probability. At the time being, possibly I'm going to use the one indicating number of outcomes rather than probability, but you might see later, right? Okay, so during COVID-19 lockdown, students need to study online, so that's what you are doing. Okay, on a survey of 50 students, it is found that 20 of them watch videos, 35 of them use textbooks, and 10 of them neither watch videos or textbooks. Okay, so basically you could categorize watching videos. Okay, watching videos is what we call, I use V to represent this event. Use textbooks. Okay, so that's T, another event. Okay, so okay, for first one, if one student is picked randomly from the group, determine the probability that the student use both videos and textbooks. Okay, so what kind of probability it is? You see the word and, so use videos and textbooks as means of their studying. That's for one student, he or she uses videos and textbooks as both of their means for studying, right? So that means it's asking for the probability of what? Intersection or union. It should be intersection because you see the word and, that means happens at the same time. So you are going to answer this one. Oh, sorry, not A anymore. It's V and T, right? So you are going to answer the probability of video and textbook at the same time. All right. Okay. So how can we do this? Because you know that 10 of them neither watch video. Okay, so for this one, 10 is about not video and not textbook. All right. Okay, so you got video 35. Video 20, textbook 35. Total there are 50. All right. So it's difficult to just like that to see how many are there for intersection of V and T. So you better draw a Venn diagram. All right. So here is the Venn diagram we're going to draw. Okay. Now the size of the circle doesn't matter, right? So union, it's not union. It's called universal set. The total number of students 50. So there are 50 students, and we will have this is what we call V. This is what we call textbook, and there are 10 of them neither watch video or textbook. That means outside two circles that would be 10. So let's write 10 here. Okay, let's fill in the circles. Okay, so which part do we need to fill in first? Remember always this part. Okay, so if you don't have the information for this part, you just take an X, but still it's important to have that. Okay, 20 of them watching videos, 20 take away X, 35 of them using textbook. So it would be just like this. I emphasize the use of Venn diagram many times now. Okay, right, so and you have to add them up, add each 4 regions together to get 50, right? So okay, so after solving this, you will see X will be 15. So that means 15 students, they do both. So probability, so let's do here, probability of V and T would be just number of V and T over number of students in the universal set. That 15 over 50. So that would that's 3 over 10. Yep, is that 3 over 10? Okay, B. Okay, try to see B. For B, determine the probability that randomly picked students either watches videos or use textbook. Okay, either watch videos or use textbook. Okay, so is V is T, but this time is or, so that means it should be union, because either, so you need to include all students who including video and all students who uses textbook. Anyone either watching a video or using textbook should be included. Okay, so in this case, what you are going to do is going to find V union T, and of course we see they are not mutually exclusive, right? Because you've already got that intersection non-zero. Okay, so that means not mutually exclusive, so you need to apply the addition rule like this. Okay, when you apply this rule, PV means number of, okay, so we got V as 20, alright, so 20 over 50, textbook 35, and take away, that's intersection. Okay, and for this one you got 4 over 5, that would be the answer. You'll get that. Alright, okay, sorry. Okay, no problem. See what I'm going to do. Alright, so you need to determine what kinds of events are you going to deal with, and either is an intersection of two events or the union of two events for this type of question. It's not just single event, more than one single event. Alright, so of course you can use a previous knowledge to add all the numbers into two circles and divide by 50. That also get you the answer, but for this video, I'm demonstrating how to use the addition rule, so that's why I'm going to use it whenever possible, but there are always other ways to do it. Okay, so here's another question. Possibly you can think of that first and see what happens. You might draw a Venn diagram, but actually this is not quite necessary for this question, because the structure of the question, they give you everything. Alright, so in a year 11 home group class of 25 students, 6 of them are in class of mathematical methods, 6 of them is physics class. Both are my classes. It is known that 4 of them are in both method and physics. Okay, so again you see two categories. One is mathematical class, method class, alright. The other is physics class. Okay, let's denote that mathematical class as M, and that physics class as P, as two events. You might be in mathematical class, might be in physics class, or neither of them, right? Okay, 4 of them are in both method. Okay, so you need to interpret this very carefully. 4 of them in both method and physics class. So what do we mean by this 4? Okay, so this 4 means P and M, right? So P intersect M. Okay, so that 4 means number of students in both math class and the physics class. There are 4 of them, and you are going to find the probability that's a randomly picked students from that home group study either mathematical methods or physics. Okay, so it's again math, physics, but this time or. So or means union. Okay, so you are going to find the probability of a union of two events. Alright, so that's what you are going to find. Okay, and of course they are not mutually exclusive. You can both study method and physics like some of my students are doing. Okay, so they are not mutually exclusive. So you are going to use this rule, right? And next thing you are going to check, do we have enough information? Yes, because we've already already given by the question that 4 is the number of students studying both subjects. Okay, so let's do one by one. PM, probability of studying mathematical methods. Alright, so there are 6 of them, 6 out of 25, and 8 of them studying physics. You take away 4 of them studying both. Alright, so that will give you 10 out of 25, which is 2 over 5. Yep. That would be the case. Alright. Okay, let's move on to here. Okay, so the next thing we're going to study is, can we interpret that Venn diagram into a probability table, or what we call two-way table. Okay, so and it's very interesting because if you got 2 circles, actually you got 4 areas in that Venn diagram, namely the area which only belongs to A, the area only belongs to B, the area which belongs to both A and B, and the area which belongs to neither A nor B. Okay, so that 4 regions, 1, 2, 3, 4. Okay, and you could actually put all this information into a two-way diagram by using the column. So column 1, column 2 as B not B, that means complement of B, A not A, and then in the table each cell represents a probability of what? Intersection. So all these probability are about intersections. Alright, so that's very interesting. Okay, and then you see okay, another advanced version is that when you consider adding them, for example, if we're adding these 2 together, so A intercept B, not A intercept B, so let's see what happens. A intercept B is the second region. Okay, not A intercept B, that means only in B but not in A, that's in the third region. When you add these 2 regions together, what do you get? You get B, right? So you get B. That's how it is, right? So when you add along the row, you got A intercept B, A intercept not B. What do you get? Imagine the graph. Okay, intersect B, A intercept B means in both A and B. A intercept not B, that means only in A but not in B. So when you add them together, what do you mean? You get A, probability for A, right? So actually that table is more interesting if you add all the columns together and all the rows together, and you will get the probability of a single event. Like you got probability B, probability not B, probability A, probability not A, and when you add that's the last row or last column together, they must be 1 because A and not A, they are complementary to each other. Okay, so it's very interesting. Okay, so let's see how could we apply this table, okay, to our questions. Okay, so I would like to use our previous question, so it takes less time for you guys to reformulate the whole thing, right? Okay, during COVID-19 lockdown, students need to study online. So just like last example, if you still remember, so now we use VT to represent the 2 events, and you are good from the table. You are going to determine probably that student only watch videos. Okay, event student only watch videos. So that's what kind of probability? Only watch videos. That means not just videos, but videos intersect, not textbook. Okay, because he only watch video, you can't say PV, because some students, they watch video and use textbook. So the better way to say it, the only way to say it is probability of V and not T. Okay, right? So how could we formulate this? So let's change the content a little bit. Okay, I'm going to change the things here, okay, just make it easier, okay, to see. Sorry, I'm just lazy, I don't want to write everything, but it seems I still need to delete a lot of things. Right, okay, sorry about this. Okay, so there are too many of them. Okay, it seems we're about finished. Okay, so here for the columns I use T, not T. Here I use V, not V. Okay, so the first one should be T intercept V. For the second one should be not T intercept V. For here should be T intercept not V. For here should be not T intercept not V. Okay, so what you are going to do, you are going to find V intercept not T, right? V intercept not T. Okay, so you are going to find this green circle, okay? And this, when you add this, the first columns together, you got T, you got not T. When you add the first row together, you got V, you got not V. Okay, so let's see what number have we already got. Okay, you already got that 20 of them watching videos, so you've already got this one. So this is 20 over what? Over 50. Okay, so you've already got this one. 35 of them use textbook. Okay, and you've already got this one. 30 of them use textbook. Only, 35 of them. Okay. Alright. And also you've got 10 of them neither watch videos or use textbooks. Okay, so you got this one. I use different colors. Right, so 10 out of 50. Okay, so how could we find what we need to find over here? Okay, it's not that difficult, because remember that if you got this one, so the next thing what I'm going to find is to find this one. So see the sequence what I'm doing. If I found this P not T, then I know the green box plus that blue number 10 or 50 will equals probability not T. Okay, so I'm going to find this one. Okay, so from the table, so this one is what I'm going to find. So this is the first step I'm going to do. So I'm going to find this one, which is 1 minus PT, right? Because that's what we call complementary events. Okay, so that will give you 15 over 30. Alright, so then I know for the green box, if I'm going to find this, that will be our second step. Okay, the sequence is very important. Okay, so I know this plus, that's 10 over 50, will be this 15 over 50, right? Okay, because along the column, okay, they add up to becomes the bottom number. Okay, so and this will be 15 over 50, take away 10 over 50, that will be 5 over 1 over 10. That's it. Alright, it's done. Okay, so you see how to use the table. First, you need to construct the table into their probability, and then you need to put numbers into put the given information into the table, and you just remember that's how to maneuver by using the definition of complementary events, and also you know the relationship between the sum of the column and sum of the row will be equal to the last element in that row and in that column, and then in the end you just think of one way to do it. Normally there will be in 2 steps, then you can find the result. Okay, so let's try another one. Okay, so I'm going to use the same information as before. Okay, so it's about home group question. Okay, we understand this. I'm not going to repeat all the things. From the table, determine the probability that a randomly picked student from that home group studying neither physics nor mathematical methods. Okay, so that's the probability you are going to find. Okay, so this is a probability neither physics, that's not P, nor mathematical method, that's not. Okay, so let's construct the table. Okay, like what we've done the table before. Okay, so remember you need basically 4 rows and 4 columns, right? So that's okay, so we understand that for this question is we need to deal with 2 situations, 2 cases. One is the event that's the student studying mathematical method, the other is studying physics. Okay, so there are 2 events. So let's say this is the event M, this is the complement of event M. Okay, studying math, not studying math, right? Studying physics, not studying physics. Alright, okay, then you understand. Okay, so the probability over here is what we call PM. That's the probability of a student studying math. That's the probability not studying math. And these 2 probability, when you add up, they equals 1. And here, this is probability of studying physics, not studying physics. Alright, okay, let's see what we're going to find. So the question is about, you need to find the probability that a randomly picked student from that home group studying neither physics nor mathematical methods. So which cell we're going to find. Okay, so no physics and no math, and they happen together. So that means the intersection should be this cell. So you are going to find this one. Alright, so what information we've already given by the question. Okay, so we know that 6 of them in the method class. Okay, so in terms of probability, that means 6 over 25. So that's a given. Also, there are 8 of them in physics class. Okay, so this number is also given. Okay, from these 2 numbers. And we also have 4 of them are in both method and physics class. So it should be here. That's method intersect physics. Okay, so how many of them? Should be 4 of them. Alright, so that's 4 over 25. Okay, so the question is, how could we find that's the yellow box? Okay, so to find the yellow box, you need to use addition or subtraction along the row or along the column. Okay, so let's see the column. If we consider the column for PM pi, that means probability of not studying math. We know that this number should equal 1 take away 6 over 25, right? Because the two probability add together equals 1 because they are complementary events. Okay, so that basically we could do it like this. Okay, so that's how we get this number. After we get this number, if we can find the number of this blue cell, then we can find the yellow, right? How can we find the blue cell? When you consider the second row, I mean the row starting with P, right? So along this row, let me highlight this. Okay, along this row, you could see we got two numbers already. So you can use 8 over 25 to take away 4 over 25 to get this number. So that's the probability not taking method but studying physics. So it's physics but no math. Okay, no method, sorry. Okay, so this probability can be found by 8 over 25 take away 4 over 25 and you will give 4 over 25. So that's 4 over 25. Okay, so now when you consider this column, you can find the yellow. Okay, you could find the answer in the yellow box. So that's probability, no method, and no physics. They intersect, right? So use this number to take away this number. Okay, so it would be 15 over 25. Right, alright, so we could answer the question now. Therefore, okay, neither physics nor mathematical methods. The probability of this one is 15 over 25. When you simplify it, 3 over 5, that's it. Okay, all good? Okay, so let's have an overview of what method, what kinds of procedure are we going to do. First, you draw the table and you label the events and its complementary events. Okay, there are two such events. So one is on the row, the other is on columns. Okay, so and then you put in all the information from the question they give you. Remember, each cell, the 4 middle cells are all about the intersection of events, right? And they sum up, you could get the total probability of certain events. All right, okay, then after that, you need to highlight which cell or which box are you going to find. You need to find out what information do you need to enable you to find out the answer. All right, okay, let's have a look for last question. Okay, so for this question, it's about the students in Mackay. Okay, so we know that 80% of high school students participate in sport in Mackay, and 60% of high school students are born in Mackay. They also show that 45% of students are born in Mackay and participate in sports. Okay, use this information to find the probability that students selected at random is not born in Mackay. Okay, so what do you need to find? Okay, you need to find this probability not in Mackay. Okay, not born in Mackay. So there are two events. All right, so one event is participating in sports. So let's denote this event as S for sports, and the other one is born in Mackay. So let me denote this as M. All right, and the probability, so part A is about the probability not born in Mackay. Alright, so how could we do that? Okay, how do we know that? Of course, you can, if you just look at the information they give you is that difficult to find? No, because you see that 60% is given, that's born in Mackay, so that 60% actually, when you use probability notation, okay, it should be probability of M is born in Mackay. Okay, so when A is about not born in Mackay, so these two events are actually, they are complementary events. Alright, so it's not that difficult to find. So for part A, it's really easy. You just apply the not in Mackay, not born in Mackay. Okay, so it's 40%, so possibly it's easier for us to write in decimal number. Okay, let's see B. The probability that a student selected random is not born in Mackay and does not participate in sports. Okay, so there are two things. So this probability is about not born in Mackay, so that's M dash, and does not participate in sports. Okay, and not participating in sports, so S dash. Okay, so what information do we have? We have 60%, which is probability of M, 80%, which is probability of S participating in sports. Alright, and also 65% is what we call probability of Mackay and sports. Okay, right, so that's what we have. We have three probabilities and plus the one we found in A, so we got four probabilities. So can you think of the answer just right away now? It's difficult, right? So that's why we need to draw the table to help us. Okay, let's draw the table again. Okay, so again, let's okay, so let's see the table. This is table. This is table, right? Okay, let's write. Okay, so still remember how to write the answers, right? Okay, so let's say this is Mackay, not born in Mackay, participating in sport, not participating in sports. Okay, so something we've already know, which is born in Mackay, so PM equals 0.6, not born in Mackay, 0.4. So these two numbers add up to 1. Okay, and participating in sports, 80%. So PS 0.8. So that means this one would be 0.2, right? Okay. Right, so and also you have PM intercept S. Okay, so it's this. Okay, so that's 0.45. Okay, 45%. So what are we going to find? You're going to find the probability not born in Mackay and not participating in any sport. So this is our target. Okay, so for our target, you might either use the row or use the columns. Okay, possibly this time I'm going to use the column. I'm going to consider this column. Okay, when we consider this column, I have to find the probability here in the blue box. Okay, I need to find that. Okay, what's the probability of this one? Okay, so this what is the probability what we call not born in Mackay but participating in sports. Okay, so that probability can be found by 0.8, take away 0.45. Okay, so this will be 0.35. Okay, then it's okay. Now you could find the yellow box. All right, how could we find the thing in the yellow box? Okay, so that's P not born in Mackay and not participating in sports. Okay, so obviously we should use 0.4 to take away 0.35. So that's 0.05. Okay, so that's it. So if I answer the question, okay, so the answer would be probability not born in Mackay and also not participating in sport. 0.5 is really small number. Okay, that's it. Okay, so that's all in this video. Okay, so in terms of the practice, okay, I know I possibly put a lot of question here is 10E and 10F. Okay, so again, you don't need to do all of them. For example, if you see question 8 to question 11, they are very similar. Possibly just do one of them to make sure you understand what it is about. All right, but you need to do some of them, okay, to make sure you understand the language or probability. They are not that difficult because you've got foundation in year 10, so that's why we kind of just give you kind of revision was using new language, but actually the essential idea would be pretty much the same. Okay, if you have any problem, please send me emails, or you can ask your question in OneNote or even in the YouTube. I will welcome. All right, we see you next time. Bye bye.